How do you measure angles? In degrees. What's a degree?
16 degrees.
That's a good idea of where we're going with when we talk about a degree. He's literally not listening. All right, so when you talk about 1 degree, for this angle being 1 degree angle, and you say it's 1/360th of a circle, it's a little ambiguous. When I think of 1/360th of a circle, I think about this arc right here. And if we talk about the central angle, where this is the center of the circle, and we connect to a piece of the circle that is 1/360th of the circumference, the angle generated by the 2 radii is 1 degree. It's 1/360th of the circumference. So this arc is 1/360th of the circumference. Okay? That's where a degree comes from. Why did they choose 1/360th? I have no idea on that. I'm sure there is a very logical reason behind it, but history of math is not my strong suit. But I'm sure there's a reason. Okay? Most of the work that you've done, if not all of the work that you've done, has been in degrees when you talk about measures of angles and measures of arcs. Remember, we're talking about angles right now. The first thing that we want to talk about with respect to the angles is we're going to talk about standard position, and that way we're all talking about angles that are created the same way. And the way I think about this is angles always have an initial side and a terminal side, a beginning and an end. Angles in standard position are always measured from horizontal right in a counterclockwise direction. So starting at horizontal right and measuring up. Horizontal right is the initial side, the terminal side is wherever you choose to end, and the measure of the angle between those 2 rays is the angle in standard position. Angles are not going to just be acute or obtuse, or a right angle or a straight angle. Angles can also be more than 180, more than 270, more than 360. We can have measurements of angles that are negative and positive, more and less than 360 degrees, more and less than 0 degrees. There is no restriction on how to measure an angle. Angles more than 360 constitute a multiple revolution. Angles less than 0 constitute going in the opposite direction of these angles. So instead of going counterclockwise, a negative angle would go clockwise. We are primarily concerned with angles in what I would call, quote unquote, the first revolution. And the first revolution starts at 0 degrees, goes counterclockwise 1 revolution to 360 degrees. Now again, that doesn't mean that we can't have angles of other measurements, but as you progress through your mathematics, we spend a lot of time in the first revolution. It's important to understand what we mean when we talk about standard position, because we are going to ask you to create angles in standard position and measure angles in standard position. origin is the intersection of those two red lines. It's meant to be the center of the circle. I know that it doesn't quite look like it is, but let's not get overly touchy on that. The distance from the origin to a point on the circle is called what? Radius. If you draw a segment from the origin or the center of the circle to any point on the circle, you have a radius. Now, I know some of you speak multiple languages and you know you're very versatile in your ability to talk in those languages. Mathematics has other languages as well, and in this particular case I'm referring to the measurement of an angle. So this right here is a radius. How many of those radii would it take to cover the circle on the circle? A lot. Thank you for the a lot. How many would it take? How many? If I took this radius and I like it was a piece of string and you put the string on the circle, how many? 700. So I would need 720 pieces of string to lay on this circle all the way around. 720 of these. So like, I mean that looks like, here, to give you an idea. This is maybe a little bit less than a foot long. Not literally my foot, but meaning around 12 inches. So do you really think from here to here is around 720 feet? Because that's what you're telling me. That doesn't make sense, does it? But you with me on the idea of 720 is a fine guess for whatever reason, but it doesn't seem logical. Okay? 3.14 of these. And so I need an infinite number of these to cover the circle? Again, do you think that that could possibly be true? Let's say that I took a string, Matt, and I put it around here. And then I took the string off and I measured it. You're telling me the length of that string is now infinite.
Are you talking about round? Or around the circle?
Like, for example, I took this and I put it here. My question is, how many pieces of string would I need to lay on the circle?
Oh, I thought you were saying the area covering the
How many radii, if I put them on the circle, would it take to go around the circle?
The two pile, like the circumference. Two piles.
Get more. 360 of those. Again, all of these are great ideas, and I see where they're coming from. But again, how many of them did I put on the circle so far? And you need 359 more, do you think, to get to there? Does it look like that could be? Do you think it'll be more or less than 359 more? By a lot or a little? So you mean 100? Let's think about it. I need to do this how many more times until the circle is covered in green? You said 360 more, 359 more. Then you said 180 more. Does it look like it? I need 180. Maybe you're not understanding my question. If I put another radius, tell me when I should stop for that radius to end. Okay, so maybe here. And then, so I'm almost halfway and I've only done 3, but you want me to go 180. Does it, hey, does it make sense that we need that many? I'm not saying that. I'm saying, do you really think we need 180 of these? Like if I took this and made 180 of them, we'd be at the end of the hall. Do you agree with that?
Yes.
Do you agree that that piece of string would go around this circle a whole bunch of times? You sure?
Yes.
Okay. And when I say a whole bunch, I mean a whole bunch. Julia?
Would you use pi r squared?
No, pi r squared has to do with what? Pi r squared does have to do with circles, but what do you find with pi r squared? That's the area. And we're putting it on the circle, Rachel?
2 pi.
You need 2 pi radii. If you have 2 pi, that's how you say the plural of radius. Right? What do you want me to say? 2 pi radii? Well, that's from you may know, I've heard of that famous rapper, 2 pi. That's from one of his songs. 2 pi radii. No, I'm sure that's from one of his songs. That guy's bad ace right there. Watch out for 2 pi. So 2 pi r is the circumference of a circle. And r is the radius. So how many radii do I need? You would need 2 pi. Now what we're concerned with is a new way to measure angles. When you lay that radius on the edge of the circle in standard position, and we look at this angle right here, this angle theta has a measure of 1 radian. The measure of that angle right there is 1 radian. The measure of this angle right here in standard position, 2 radians. If we put another radius on here, you'd get somewhere right about here. This angle, so this color, this angle right here would be 3 radians. One time around the circle, 360 degrees, right? In radians, 1 revolution is equal to 2 pi radians. In the same way that 1 revolution is equal to 360 degrees. Radian measure is a new way or a different way for you to measure angles. Radian measurement is just a different way for you to measure angles. Now in my classes right now, in the honors classes, we work with radians every day. I have about a half a dozen students in 2 classes, it might be a little bit more, but it's around 6, who refuse to learn radians. And of those kids, when they have a problem in radians and they have to convert to degrees and convert back, they almost, without exception, make mistakes at more than a 50% rate. So I'm telling you right now, for those of you going on, don't blow off learning radians. Learn them right away. A radian measure, arc length divided by the radius will give you the radian measure, by definition. S is arc length. R is your radius. Theta is your angle. So S, if we solve for the arc length, is going to be theta times R, only when you are talking about radians. This does not work unless you're talking about radians. Your angle measurement is the ratio of the arc length, a part of the circle, divided by the radius. That'll tell you how many radians are in that central angle. When you talk about degrees, the arc length in degrees is n over 360, the number of degrees in the angle divided by 360, times 2 pi r. And you could solve for theta or n also in that formula. But what we want you to understand is this right here is going to be a radian measurement on occasion. And you need to understand this is just a different unit of measure. You can measure in metric, you can measure in standard units. Still measuring the same thing. They still mean the same thing. You need to be able to work in both. One revolution is one revolution. They're equal. In degrees, one revolution is 360 degrees. In radians, one revolution is 2 pi radians. If you divide both of these by 2, then 180 degrees is equal to 1 pi radian. If that's true, what will 1 degree be equal to? Pi divided by 180 radians. We're doing algebra again. Imagine that. If we take the same equation and we come to this path and we get to 180 degrees, what does 1 radian equal? 180 over pi degrees. 1 radian is 180 over pi degrees. 1 degree is pi over 180 radians. Why do we need to use those? Why do we need to know those? Because if you know those two things, you can convert from degrees to radians simply by multiplying by pi over 180. So for example, if you have 60 degrees, and you want to know how many radians is that? 60 degrees times pi over 180 is going to give you pi over 3 radians. To convert from degrees to radians, you multiply by pi over 180. If you have pi over 3 radians, and you want to convert from radians to degrees, you're going to multiply by 180 over pi. What cross cancels here? In this case, the pi cross cancels, and 180 divided by 3 is 60 degrees. These two conversions, you need to keep them straight because obviously they're very similar. When you want radians, pi is in the top. When you're going from degrees to radians, pi is in the top because pi is part of a radian measure. Yeah, me too. I'm going to be blinking you standing up in the corner in a minute. When you want to end in degrees, the pi is in the bottom because you're trying to get rid of the pi from the main angle measurement that you have. Yep.
So what about that poster that I found one day a while ago that has the big circle, it has
Those are radian angle measurements. That's what we're talking about right now. And if you hang on, we'll get there. But the conversions, you have to know that. You have to memorize them. Okay, you can derive them if you ever get stuck. You can always start with what's equal. 360 degrees is equal to 2 pi radians. Divide by 2, and then divide by 180. Or just divide by 360 if you want right from the get-go. That gives you the 1 degree. That tells you how to convert into radians, from degrees to radians. Every 1 degree, pi over 180 radians. And over here, you do just the same thing, except you divide by 2 pi or by pi. And if you want the degrees, you multiply by 180 over the pi. Okay? Remember, one revolution is either 2 pi radians, 360 degrees. How are you going to know when I do this and I say, theta is equal to 28? What am I talking about? How do you know?
It's not.
It's a degree sign.
There's no degree sign, so automatically, this means we have to be talking about radians. If you do not put a degree sign down, right, Ryan? If you don't put a degree sign, I'm going to assume that you mean radians. Some of you are going to make that mistake on the quiz tomorrow. It's a careless mistake, and it's one that you haven't had a lot of time to practice. You need to practice it tonight. When you don't put a degree symbol, you're implying radians. Remember, 1 revolution, 2 pi, 360. A half a revolution is pi radian, 180 degrees. And again, these are your conversions. Okay? Did I do something wrong?
No, it's standing like right there in,
You don't want me to stand here?
oh, can we see the first? Because I can't see it all.
Can you see it now?
See it now.
So you need to not complain after the fact, just say, I didn't see that sign, and as always, we'll go right back. But I can't read your minds. I do the best I can. I'm doing the best I can. But all you have to do is tell me. But I won't know unless you say something. Well, thanks, sir. Why do we not have
Like,
anything in there?
like radians.
Okay, so you have 196 degrees, you have 1.35 radians, you have 2.5 pi radians. I want you to convert this one to degrees, this one, this one to radians, this one to degrees, and this one to degrees. So, see what you can do. All right, Parker, take me through the first one.
You're converting degrees to radians, so you multiply 196 by pi over 180,
Okay?
and then I cross cancel to get 49 degrees and 45 degrees. 196.
Actually the symbols, this is something that we don't teach you. You probably haven't been taught, but when you have degrees divided by degrees, the units of measure actually cancel as well. Okay? So degrees divided by degrees, you don't have degrees anymore. 196 and it reduced how? 49
Over 45.
over what?
49 over 45.
40. Brittany, can you grab that and just say the students speaking, operation room students speaking? 49, 45 pi radians. We don't need anything there. Thanks. Hello. I didn't hear you faded out. Yeah? Yeah, go ahead. No, you don't need to do that. We'll figure it out another time. All right. Yeah. Oh, cool. When is it? Oh, cool. All right. All right, so you're not going to be there when I get there. All right, I'll see you when you get back. Okay, bye. So again, You don't need to write the word radians typically when you talk about an angle measurement, but when we're doing a conversion, you're going to want to do that. Okay? Emma, how about the next one? 1.35 radians. How am I going to do the conversion?
Multiply by 180.
180 over pi, because we want to end up in degrees, so we're losing the pi. And what's 1.35 times 180 going to give you? 243 exact?
Yeah.
Wow, very nice. 243 over pi degrees. When you can give me exact values, I'd rather exact values. If that 243, I was expecting a decimal, an ugly decimal that went on forever. If that was the case, then you would divide by pi and round to how many places? 3. If it's 243 over pi, let's leave it like that. Okay? Yeah. When you do what? Solve. We're not solving.
We're not solving. Multiply them together.
1.35 times 180. Which is what we got, over pi. If you divide by pi, you're going to get a decimal and you're going to have to round. When you can get exact values, we want exact values. If this were a decimal, this is like deja vu.
Yeah.
If this were a decimal, 243.7, then divide by pi, round to 3 decimal places. Should we replay that? Okay. Perfect. Allie, what'd you get on this one? So what am I going to do? 2.5 pi, and I'm going to multiply by 180 over pi. We love it when it's a radian with pi. The pi's cancel. And 2.5 times 180 ends up being 450. What's that? You're not going to write the word degrees. I know you're not. So I'm just developing good habits, hopefully, in you. Right? Okay, so convert this one to radians. Convert this one to radians. This time you're going to need to potentially utilize the pi because you're going to get something that's not quite so pretty as the last time. As close as we can, and that rounding thing, we don't want to round in the problem, only at the end of the problem. Dominic, what do we do here?
233.23 180 over 5 over 180.
Okay.
And then you get 4.071.
When you did it, after you plugged in the pi and the whole deal. So what is it? 4.071 radians. Anyone getting anything different for that? Okay. So now we're going to start talking about different names for angles and different terminology. Some of it is very relevant. Some of it is more information than you need right now. First of all, we want to talk about coterminal angles. Those are angles that have the same coterminal side. In other words, they stop. You go around and around and around, stop. Where they stop is the terminal side. So what I've done up here is I've drawn 3 angles, a green one, a red one, and a blue one for you to recognize as coterminal. They're all ending on this vertical line right here, which is an angle that you're familiar with. So the green angle is very easy. It's 90 degrees, or pi over 2 radians. Okay? But if you kept going like the blue angle, we start here and we're going from horizontal right, we go here, but we keep going all the way around back to where we started, and then we keep going again to here. That's one complete revolution, which is how many degrees? 360. Plus a quarter of a revolution, which is 90, giving you 450 degrees for the angle in degrees. Coterminal, 90, 450. Pi over 2 and 5 pi over 2, radians. How do we get there? We just keep adding 2 pi, one more revolution. Or we keep adding 360. We got 90 plus 360, 450. If we go the other way, the red angle goes all the way around to here, 3/4 of the way is a negative 270 degrees. Or a negative 3 pi over 2 radians. Everybody seeing that? Everyone but Michaela?
I'm awake.
All right, so all of these are coterminal. All of these are coterminal, and some of these are all the same, just different measurements. How do we get coterminal angles? In degrees, add 360, or subtract 360. So if we're talking about a 90-degree angle, just keep adding 360, or subtracting 360, and that'll give you another coterminal angle. Coterminal angles in radians, add 2 pi. One of the biggest weaknesses of all of my students is that they can't add and subtract fractions. I assure you, it will be preventative of your success in honors pre-calc and in pre-calc if you cannot add fractions. So you better get really good at it. And stop saying, oh, it's okay that I don't know how to do this thing that we learned in 5th grade. My calculator will do it for me. Not going to help you.
Can we like choose whether we want to use the radians way or the degree way?
Well, if I ask you to do an angle that's in radians, you need to be in radians.
Okay.
And if I ask for degrees, you got to be in degrees. The problems are going to direct you.
Oh, okay.
It's not, made a mistake?
I didn't like it.
Okay.
Did you already make copies?
No?
I'm gonna do them now.
I see.
Okay. See him?
Yep.
So, degrees, same terminal side, you can take any angle and add 360 n. And n can be positive or negative. As long as n is integer. You can't take half of a rotation. If you're dealing with radians, you're going to take theta plus 2 pi n. You're just going to keep adding multiples of 2 pi. Even if that multiple is a negative, it'll still give you a coterminal angle. So for example, pi over 2 plus 2 pi becomes pi over 2 plus 4 pi over 2 to get 5 pi over 2. And you could add 4 pi over 2 to get 9 pi over 2. And again to get 13 pi over 2. And 17 pi over 2. And you can subtract to get negative 3 pi over 2. Negative minus 7 pi over 2. You can just keep going negative if you want. I haven't talked about those yet, Raven. Your patience is overwhelming me today. Taking all my thunder away, I filled all these things and quadrantal angles means that the terminal side of your angle is on the x or y axis. So when we come here and we go straight up, that's on the y-axis, 90 degrees, pi over 2 is called a quadrantal angle. When you come over here so that you're on the x-axis, pi and 180 are quadrantal angles. When you go straight down, 270, 3 pi over 2, and all the way around, 2 pi and 360, those are all your quadrantal angles. And again, we're mostly concerned about the first revolution, so those are the ones we care about most. Well, 1/2 pi radians, pi over 2, and 90 degrees are the same. Absolutely. Just like pi and 180, 270 and 3 pi over 2, and 2 pi and 360. The inside, I got the angles in degrees. On the outside, I got the angles in radians. miss somebody? Okay. Really, the big thing here is coterminal angles. And you should be able to find them pretty easily. How many coterminal angles are there for, let's say, 80 degrees? We could sit here and keep adding 360 over and over and over again forever. Remember, standard position, horizontal right, counterclockwise. If you go horizontal right clockwise, you're going to have everything will be wrong for you. Coterminal angles stop at the same location. They just have multiple revolutions built into them. Positive angles, horizontal right, going counterclockwise. Negative angles, horizontal right, going clockwise. And quadrantal angles are the ones, this doesn't sound right, but it's, for me it makes sense. Quadrantal angles are the ones on the corners. Here, here, here. Yes, I know, circles don't have corners.
So for coterminal angles, does it just have to be in the same terminal, or like where
It's the we're always talking about standard position, right?
Yeah.
So let's say we're talking about this terminal side. So this would be the first angle. There's your second. And then you can keep going around and around and around and around. It's all about that, wherever that stops, so to speak. Does that make sense?
Yeah.
Right. So these are the angles that we kind of talked about yesterday in radians. So we talked about 30 degrees, 45 degrees, and 60 degrees. In radians, you can, yes, Rachel, sorry.
I didn't catch what standard position was.
Standard position is always from horizontal right going counterclockwise. That's how we draw our angles. In other words, I don't want you to tell me we're talking about this angle right here. That's not going to mean anything to anybody. We always start at horizontal right in here, and we're going in this direction, up to quadrant 1 and around. Does that make sense? You know what I mean when I say quadrant 1? Quadrant 1, 2, 3, and 4 from the coordinate plane. Any bells ringing? And if not, you want to copy this down. The X and Y axis gives you 4 regions, right? Hardly. Turn it off. Put it away. So the 4 regions, the one that we care most about is quadrant 1, because in quadrant 1, everybody's positive. It's such a great place to live. No negativity, life is good, how's it going? The friends are they're all just so happy to be there. But when you get over here, in quadrant 2, the X's are negatives. Well, it's so hard to be around them. And then the Y's are positive, so they kind of balance each other out. In quadrant 3, everybody's negative. Nobody wants to be there, but geez, sometimes you have to go visit. It's not fun. And in quadrant 4, the X's are positive, but the Y's are negative. Okay? So we're going to start horizontal right and go through the quadrants just like that, in the order that they're labeled. The quadrant that we care most about is 1, pi over 6, pi over 4, pi over 3 radians. 0, pi over 2, pi, 3 pi over 2. The quadrantals are always going to be important for us, but that's what we want. So you want to be very familiar with these. Later on, when you go to your next class, we'll talk about how do you get these other angles. If you know those, you can find these easy. These are easy to find. These are easy to find. Don't really care today. Really only worry about quadrant 1 today.
Can you do anything with like the coordinate system, like I don't know?
You mean like if writing coordinates of the points on the circle?
Yeah.
Yeah, absolutely, and you will. But again, we spend a whole quarter here working on those ideas in honors, and you'll absolutely spend a lot of time working with those concepts. But right now, again, remember we're just trying to say, here it is, Be aware, and when you see it, you don't go, oh crap, I've never seen this before. Well, you might say that. But you've only had a couple days, so it'll come back to you pretty well. What I want you to be able to do is, can you graph this angle? Okay? And then can you give me coterminal angles? One positive and one negative with pi over 4. What am I going to say for an angle? Give me a coterminal, Diana. You can give me either one since you're first. Give me a coterminal to pi over 4. Okay, let's go back. How do we do it? To find coterminal angles in radians, what do? Add 2 pi. So what's our angle? What angle are we working with? No, I'm asking which angle are we working with, literally? Pi over 4. How do we find a coterminal angle with that? And what's 2 pi plus pi over 4? Okay, so how's this working for you? Sitting here going, I don't know what pi over 4 and plus 2 pi is. It's not working very well, right? What should you be doing? No, because if you need to really ask that question, we have a lot of problems. Now, you may really not know how to add those. But again, if you don't know how to add 2 numbers, and you're in Algebra 2, I know you know how to do it. How about if we wrote it down? Instead of trying to do it in our head. Well, how do I add these? It would be nice if it was that simple. Because like 1 over 3 plus 1 over 5 would be 2 over 8, right? Yeah, that's not true. You know that. How do you add these numbers? Right. What's it going to be? Oh, dude. What was that all about? What do I multiply by 4? What did you want me to multiply by? I just didn't hear you. Over? Like this, right? And in the new math, when you multiply 4 times 2 pi, 8 pi over 4 plus pi over 4, 9 pi over 4. That's your coterminal angle. Okay? You have to be able to do this. You have to be able to add fractions. And if you're moving on to the next class and you can't do it, you want to know the one thing that will help you a great deal? Learn how to add fractions. No, I want you to write 9 pi over 4. It'll help you in the long run.
Where'd you get the 2 pi from?
The 2 pi is from the notes 3 slides ago. If you want to find a coterminal angle, so here's my angle, pi over 4. Go around the circle again. How far around the circle is it? What's the measure of one time around? But we're not in degrees. 1 revolution is 360 degrees. What else is it? 2 pi radians. 2 pi. That's why we're adding the 2 pi. So the angle would look like this when you draw it. So that red angle is going to be 9 pi over 4 radians.
So on the notes it said to add 2 pi n.
Okay, well n is 1 if you're only going around one time. You can make n be 58 if that's your favorite number.
So n is just the number of times going around.
Correct. So we get the pi over 4. We can add 2 pi once, twice, 3 times, 4 times, 5. All of those stops will be a coterminal angle. And then if we make n -1, we'll be doing pi over 4 minus 2 pi, and we'll be getting negative, negative 7 pi over 4. And that angle would look like this when we draw it. It would go in the down and around direction, clockwise instead of counterclockwise.
Do we have to draw the arrows and all the angles, Joe?
I'm open to suggestions. If they ask you to, it says sketch the results, either you're going to have to do something telepathically, or you're going to need to draw them. Now, if it gets too messy on one coordinate system, just draw 3 different coordinate systems, and then I'll be fine with that. Nothing wrong with that.
So where would 9 pi over 4 be?
Right here. 9 pi over 4 is the red one.
Oh, so it's
So we went pi over 4.
graph like that, and then this is fine too. So you do pi over 4, 9 pi over 4, and then the next one.
Negative 7 pi over 4. You could have done you could have done 17 pi over 4 also. You could have done 25 pi over 4. You have all kinds of options, but the more times around, it gets kind of muddled. You know, you start here and you go, okay, 1 time around, 2, 3, there's my angle. It gets kind of confusing. So if you go to that, you might want to do 1 per coordinate plane. All right. Everybody good here? I thought I missed somebody. What? Hanging on? So then same drill with 225 degrees. See if you can sketch that and find me a positive and a negative terminal. You're going to tell me when to stop for my angle. No, I just want to draw the angle first. So let's find where I go to 225.
Like right there.
Here?
Or no. Or right, I guess right there.
Right here. It's like leading the dog here, the water, right here. Okay, so there's 225. And what was a coterminal angle for 225?
585.
How'd you get it?
Add
Added 360 and got 585 degrees. So that we would look like all the way to here, and then one more time around. There's your 585. Yes. Yes, sir. What do you think? Look at the question. Tell me what you should be doing the question in. Degrees, because it's talking about 225 degrees. So you need a coterminal, 585 degrees. Ben, how about a negative 1?
So, 225
Yeah, I was hoping you would have already done it.
negative 135.
Negative 135 degrees, and that angle when we draw it looks like that. Yes?
if you were doing it with radians and you're finding the what would be
You're fine. But don't want to do radians right now. We did radians on this one.
yeah, I know. Sorry.
So when you take pi over 4 and subtract 2 pi, that's why it's negative 7 pi over 4. It's always 2 pi. Like when Rachel asked that question, I don't get the 2 pi n. N is just how many times around in the direction. If you choose a negative 1, it's minus 2 pi. And if you take a negative 2, you're going minus 4 pi. Not that you really want to keep going with multiple revolutions. Okay? See if you can draw these 3 angles separate standard position. So I just want you to do this and draw the terminal side of the angle. We know that the initial side is horizontal right. See if you can draw the 3 terminal sides for those angles. Have any of you had Mr. Cunningham? How would he read this angle?
Like, I don't know, you can understand it.
Yeah, what would it sound like, you know? This was in an article a while back.
Like,
Too
240.
240.
240.
Yeah, so it's
something
like
that.
your grandmother after
Yeah, it's really
a
bad.
cabbage meal.
I don't like it.
240. It was a golf joke. The Irish guy said it's 240. 240 from the pitch. And the person was looking at him. I can't get that out of my head every time I see that measure.
On a day that like they had a collaboration meeting, you guys were supposed to like really emphasize talking like and pronouncing grammatically right. And he came in our class and talked about it, and he tried saying that, but he said every single word wrong in it.
Yeah, you know, when you guys go to college, you're going to get professors and grad students teaching you classes from other. I had a guy teaching a sociology class from Soviet Union, one of the Eastern Bloc countries. Took me a week to understand him. There were people who went through the whole course. Couldn't understand a word he said. By the time we got to the end, I'm sitting in there, and I had about 12 people around me copying my notes. What did he say? What did he say? It was unreal. So, you know, you're getting warmed up with Cunningham. At least it's more or less English, yes? Poor guy. Oh, we're still going. We got that on tape. That's good. Cunningham can see that live. All right. Allie, 240. Where is it going to be?
So, starting out,
Always start horizontal right.
yeah. Go around that way and
Around here. Somewhere in here,
Yeah.
240. Make sure you label it. Make sure you put degrees on it, too.
What are some of his sayings? Some of his sayings are so ridiculous.
What's that?
Some of his sayings are like so ridiculous.
They're from another country.
I know,
They're
that
not
makes-
from around
I don't
here.
know, it just like makes like like oh.
Evan, how about 500?
Alright, we start in the normal spot.
Yep.
And you're gonna go completely around.
Okay.
And then keep going into the second quadrant.
So about halfway here. So what's the co-terminal of the first revolution? Did you figure that out? It would be 500 minus 360. So that's going to be 140, right? Or 140. So we know that's 90. That's not the 180. So somewhere in there, you would imagine that it would be more like this, because it's a little more than halfway. So this is 500 degrees, but how are you going to show it to me? You have to show all the way around to the second revolution.
would that blue line be the
Terminal side, absolutely. Okay, Julia, how about the -50? What are we doing?
Well, you start on the right foot,
Yeah.
go the opposite direction.
So we're going to go down, how far? Not very far, a little more than halfway. And it's this angle right here is -50 degrees. Okay, am I looking for an exact? No. But I would like it, if it's 50, it's more than halfway, so give me a smidge over the half. But I'm not going to get too worked up over that. But if your 50 is up here, I'm going to have a problem. Okay, if it's right next to the -90, then we're really not in the ballpark. Okay, so I think, so you know this angle right here, a little bit more than half, a little bit more than half, a little bit more than half. Okay? Get out of this stuff here. Okay, so here's your conversions again. You're getting multiple versions of this information. Nope,
No, but like.
I don't care what order the book is. So here again would be your your spokes, if you will, with all the angles and all the radian equivalents. Which quadrant do we care most about? First quadrant. Why do we care about these angles in quadrant 1? Yeah, but pretend you don't even know that they exist in there. What's important about those? They're the angles from the special right triangles. So we spend much of our time with the 30, the 45, and the 60 because they come from the triangles we know. And we don't worry about other angles like 15 degrees or 22 and a half or 75 degrees, which we can find also. We will deal with that. We will talk about how can we get there at some point in time. But it's not for this course. And it's not even at the beginning of the pre-calc work with trig. Okay? So, where you don't need that, you don't need that, you need that. So tomorrow when you come in, this is what we're going to look at. We are not looking at the sector, area, or arc length. This is all we're worried about. Make sure you copy down the questions, show your work, and identify your answers. Again, online, you can find a final exam review that is extremely comprehensive. This final exam review a lot of people get this confused. They look so much alike. Fourth period. This review is worth extra credit if you complete it. It is worth 3 points extra credit. 3. But you need to do it on a separate sheet of paper. You need to show your work, identify your answers. I will give you the answers in just a moment. It will be due on. It will be due on Wednesdays. You got. Jonathan's on fire. He's going to tear this one a lot.
You said you knew you could do it.
Where's Syed?
Say people who can't fail it if you're
Like a baby, like I took it right after the head.
You get what?
Wait, what are you talking about?
No.
It's
You will
Oh, you can fail.